Our solar system can feel like this incredible 1 in a billion miracle, right? But what if I told you that there's another one out there, a kind of cosmic cousin, that might just be even more remarkable? Let's talk about the TRAPPIST-1 system. It all kicks off with a single number, 40. That's how far away it is. 40 light years. Now, that might sound like an insane distance, but in the grand scheme of the galaxy, that's practically our next-door neighbor. Close enough for us to get a really good look. So let's get acquainted with this neighbor, shall we? Because the TRAPPIST-1 system is, in almost every way, a mind-bendingly different version of our own cosmic backyard. And the first thing you need to grasp is its scale. Or, well, the lack of it. The entire TRAPPIST-1 system, all 7 of its planets, could fit inside a space just 9 million kilometers across. Now get this, the distance from our sun to just its very first planet, Mercury, is 58 million kilometers. You could literally drop this entire solar system into that gap and still have tons of room to spare. It's this incredibly compact, miniature neighborhood. And to really understand this place, we have to start at its heart, the star. It's nothing like our sun, and that one single difference, well, it changes everything. The TRAPPIST-1 star is an ultra-cool red dwarf. It's small, it's dim, and it's barely even bigger than the planet Jupiter. We think of our sun as being normal, but really, these little, cool stars are by far the most common type out there in the galaxy. But here's where things get absolutely wild. Our sun? It's got a lifespan of about 10 billion years. A red dwarf, like TRAPPIST-1, it could keep burning for trillions of years. That's longer than the universe has even existed so far. It's a stellar marathon runner, offering an almost eternal stage for life to evolve. But that comes with some major challenges. Because the star is so cool, the planets have to huddle incredibly close to stay warm enough for liquid water. That proximity leads to something called tidal locking, where the same side of the planet always faces the star. So just imagine, one half of your world is in perpetual, scorching daylight, and the other half is locked in an endless, frozen night. On top of that, these little stars can throw off powerful, hostile solar flares. It's a really tough neighborhood for life to get a foothold. So with all those challenges laid out, let's take a little tour of the 7 known planets. Let's go searching for a world that might, just might, have beaten the odds. Our journey starts at the innermost planet, orbiting closest to that dim star, TRAPPIST-1b. Okay, so this world is a rocky one, a little bigger than Earth, but it is getting absolutely scorched by its star. It's got a thick, crushing carbon dioxide atmosphere, and a year lasts only 36 hours. So yeah, definitely not the place we're looking for. All right, moving just a little bit further out, we come to TRAPPIST-1c. Planet C is kind of like the Venus of this system. It's another rocky world, higher gravity, and it's also suffocating in a thick, toxic CO2 atmosphere. So like its sibling, it's way too hostile for life as we know it. But as we move one more orbit out, this is where things start to get interesting. We are now crossing into the inner edge of the habitable zone with TRAPPIST-1d. This world is smaller, about 70% the size of Earth, with only half the gravity. But, and this is the crucial part, it's right in that sweet spot where its temperature could be just right for liquid water to exist on its surface. For the first time on our tour, we have a real contender. But as promising as Planet D is, the next one is even better. This is the one that has scientists truly, genuinely excited. We're talking about TRAPPIST-1e. I mean, that's what scientists are calling it, and for very good reason. Meet TRAPPIST-1e, the undisputed star of this entire system. And here's why it's so incredibly special. Its size, it's nearly identical to Earth. Its gravity, it's exactly the same. Based on what we know, this is the most Earth-like planet we have ever found. This amazing combination of factors raises the tantalizing possibility of oceans, of continents, maybe even ice caps. It is, in so many ways, our planet's closest known twin. Okay, so we have this incredible candidate, but how do we get from potential to actual proof? Well, that's where our most powerful eye on the sky, the James Webb Space Telescope, comes into play. Now, before we see how Webb is investigating, it's important to know why its focus is so specific. I mean, there are other planets, right? Well, the outer ones, F and G, are almost certainly frozen ice worlds, and planet H is way out in the cold, totally outside the habitable zone. That's why the hunt for life here really centers on planet E. So the James Webb Space Telescope has a critical mission. As these planets pass in front of their star, Webb is designed to analyze the starlight that filters through their atmospheres. It's like a cosmic detective, searching for the tiny chemical fingerprints, the biosignatures, that could signal the presence of life. But this is painstaking work. It requires an immense amount of patience. We're talking months of observation just to get a basic temperature reading for a single planet 40 light years away. Webb has already started its work on the inner planets, and its gaze will eventually fall on the prime candidate, TRAPPIST-1e. And that brings us to this one final, staggering thought. A star that can burn for trillions of years offers an almost unimaginable amount of time for life to begin, to evolve, and maybe, just maybe, to build a civilization far, far older than anything we can comprehend. So the ultimate question isn't just, will we find life? It's, what kind of life will we find when we finally get a clear look?